This is our episode club, and today we have special guest with us, Professor Mohammed Noor. Woo woo! So today, if you haven't been here before, what we're going to be doing is talking about the science behind 2 Star Trek episodes. We're going to talk about Threshold in Voyager, which frankly I could not do without Mohammed here, so thank you. And then we will be doing the episode Timescape from Next Generation. But yeah, so welcome, Mohammed. I'm really happy to have you here.
Thank you. I'm honored to be here. I appreciate you inviting me.
Yay! I mean, we can't not.
Aw, you're so sweet.
Thanks. So for those of you who don't know, Mohammed and I have worked together professionally now on season 3 of Discovery. So come back to us next year, I guess.
Yeah, after the season's over.
Yeah, we'll talk about it then. We'll do a special episode then as well. But otherwise, we know each other from doing conventions and Dragon Con and all that fun stuff.
Just general fun.
Yay. Yeah, Star Trek cruise, general merriment. Yeah.
Star Trek, what's the thing? Star Trek, not
Vegas?
Fleet Command. No, the video game.
Bridge Crew.
Bridge Crew, yeah.
Also that. Yeah. Exactly. So yeah, Threshold. Oh, Threshold. We get asked about this a lot.
We do. That's usually one of the first questions. For both of us, amazingly.
Yeah. It's become one of my funniest jokes, if I do say so myself, saying that when you go to Warp 10, bad episodes happen.
It's a good comment.
So you, just a little bit, for if people haven't met you yet before, other than maybe seeing your name in the comments as we've gone, you wrote a book on...
I did.
Biology.
I think I have it right here. Does it show up?
Oh yeah,
there it is. Live long and evolve. It's basically, so my specialties are in genetics and evolution, and I teach classes in those areas. And basically, this book is essentially my introductory genetics and evolution class at Duke, but framed using examples from Star Trek. And I'm a professor, I should mention. I'm a professor at Duke University, so that's where that comes from.
That helps. That's awesome.
Yep.
Yeah, no, definitely. So this episode is a bit of a classic, as we said. This is Voyager. We're in season 2, episode 15, and this is where we see Tom Paris kind of kicking it off. Frankly, every time I watch this episode, I think it's later in the series than it actually is.
It seems like it, doesn't it?
Yeah.
It's funny.
Like, Kes
really
shows
does.
up, and I'm like, wait, we're this early? But yeah, no, this is season 2. And Tom Paris is basically testing this idea of a transwarp barrier to try to go past warp 10, the theoretical warp threshold. And when one does that, yes, and when one does that, they exist in all of space and time simultaneously. And once they do that, they can, they might be able to go home, I guess. The general premise. Yeah.
It's funny because when he popped out, he said he saw every place. I'm surprised he didn't just pop out at home and tell them, hey, by the way, Voyager's stuck in the Delta Quadrant. Can you go send a rescue fleet or something?
Right. Agreed. Yeah.
Or just use the Delta Flyer and go back and get them.
Somehow he came back. Yeah, it was really interesting. Yeah, this is a little bit like an improbability drive, but I'll do a quick rundown about how warp drive works and what warp 10 means and what these warp factors mean as well, because there's an ongoing joke that warp factors related to percentages of the speed of light change for every series, and I have an explanation for that. So but this idea of we have our sheet of space-time that you can't go faster than the speed of light on it. You have a mass, it dips the space-time, that's going to slow you down and you're not going to be able to go faster than that. Once you have no mass, then it's flat, and that's your limit. But nothing says space-time itself can't go faster than the speed of light. So that's the idea that you build this bubble of space-time around your ship, and then it propels you faster than the speed of light. And then, so your space-time is flat at your ship. The bubble of space-time is going faster than the speed of light. If you want to go even faster than that, one way you can do that is build another bubble on top of that. In that case, you're essentially exponentially increasing your speed as you go. And if you keep doing that, if you keep building these warp bubbles, which we could say your first bubble is warp factor 1, and then you're increasing your ship's speed within that, so you get, can increase it from there. Then you get up to warp factor 2, 3, 4, and then, but following that logic and exponential curves, if people remember those, you're going to reach the point where you're wrapping all of space and time around your ship, and that's, in this case, what they explain to be warp factor 10. And conceptually, that works. Like, I don't know about you, but I'm not opposed to it. And the first half of this episode makes perfect sense. And then it deteriorates super fast. but yeah, sort of.
It is space and time, right?
Yes, space and time. So this is our whole fabric, our 4-dimensional fabric of our universe, that you're wrapping around your ship, and that's really the explanation there. And yeah, exactly, physics. If you didn't understand exponential graphs now, maybe this is a good time to learn about them. But so when it comes to what the warp factors mean with relation to a specific time, and a couple examples popped up about, you know, when they've technically gone faster than the speed of light. Yeah, in All Good Things, I think they do warp factor 13. And but the way I think about it is that your ship has a mass, and that mass is going to warp space-time itself. And if you want to build a bubble around that mass, the bubble that you build is going to be kind of contingent on how massive your ship is, right? If you have a really massive Galaxy-class ship, that's going to be a big bubble to build. And your warp factor 1 will be different than the warp factor 1 on a smaller shuttle. So that's how I explain the differences. And then however you choose to scale that, you know, there's always going to be a warp factor 10 threshold, whether or not you call it 10 or you just, you know, the infinite improbability drive, as someone mentioned in there. There is still that limit where all of space and time is warped around your ship. So for me, when they're explaining this in this episode, I think the only thing that trips me up is when they keep using this transwarp. Warp versus transwarp. I personally don't... The only explanation or definition I can make up for transwarp is just the transition into and out of warp, is basically that you can only increase your bubble, build a new bubble. That's your transwarp. So your transwarp threshold is the transition into that infinite warp 10. But as a biologist, how did you find the transwarp warp factor 10 explanation?
I mean, that part I didn't understand at all. So I'm taking everything you said as like, that sounds great. I'll take that.
Okay.
I mean, honestly, I was skeptical, but I remember in one of our early talks at DragonCon several years ago, I asked you about it, and you're like, oh yeah, no, that's fine. I'm like, oh, okay, cool. I'm pleasantly surprised. The nice thing is the time piece is critical for this whole evolutionary aspect as they try to use. So that I'm glad that that's worked into the whole thing.
And along those lines too, they do a great job of using our favorite cosmological address correctly here too, that they say, you know, that your infinite exponential curve that you've reached, your asymptote of warp capabilities, is the whole universe. And they say that explicitly, that this will tap you into the entire universe. And remember, Star Trek takes place in the Milky Way galaxy, and that's much, much orders of magnitude smaller than the whole universe. So, yeah, I think the way that they do that is pretty good. There's some fun sort of technobabble with them trying to figure out why the ship can't go faster than warp 10, that it's like, maybe the nacelles aren't breaking off the ship. Maybe the ship is breaking off of the nacelles. And like, whoa.
That was cool.
It was a good one. But yeah, so he comes back and they do manage to do it. His first...
Still not entirely clear how he comes back to exactly that space-time point. I'm like, okay. That's pretty high precision there, given that the universe and infinite time. And you're like, I'm going there.
Right. I mean, I was thinking that maybe there'd be some sort of tether to keep... So you're still at the center.
Okay.
And your warp bubbles are everything.
Oh, well, this is good because this will tie later than how they were able to find the ship, like, 3 days later. I was wondering, it could be anywhere in space and time. It took you 3 days to find it. What? How is that possible?
Right.
But the tether thing makes it a little bit more likely there. I like that.
Because, yeah, you've built that bubble around. So even though you can still, like, access all of space and time, and that's where I think Janeway was talking about, where she was like, we're going to need to figure out how to find home. I was like, it's great that we can do this, but, and then his first test, he's like, I saw everything. I saw the,
and somehow understood
pompous
it.
and yeah,
Right?
yeah,
You saw and just understood and comprehended and could tell they were looking for you. Like, what?
yeah.
Okay.
So it's yeah. So I think talking through it right now, I'm kind of okay with him popping back out
The
where
tether's great. That's a great
they
idea.
are. Yeah. Um, and I mean, there's things they throw around like, oh, we're getting some quantum signatures. Where now he's showing
Gotta
up.
slip in the quantum.
Someone's popping in from subspace. We got a nice subspace call out there as well. And then I gotta say, it's pretty fabulous when he's just asleep in the med bay and he's just asleep. And the doctor's like, wake up. He wakes up. And then things start to go wrong.
Yeah, it is kind of over the top. I guess it starts a little bit weird with sort of the pain after he's having some of Neelix's coffee and stuff like that. But then, yeah, then it really goes off the rails very quickly. Like this allergic to water. That, I mean, just in and of itself, that's like, whoa, you're in like bad shape if you're allergic to water. you're in really, really bad shape, because that's like most of you. I mean, you remember like Star Trek reference, ugly bags of mostly water.
Right.
Right?
Right. Exactly. Like you would think that then before he drinks Neelix's coffee, he's like allergic to himself, right?
Yeah. So I mean, it's funny to think of what does that actually mean, allergic to yourself? Even like, does he have cells attacking his other cells? And like, I'm not exactly sure even what that means in this sort of thing. Like, I mean, typically when you have an allergic response, you have, basically your body's, you're having this inflammatory reaction. You have, things attacking, but it's not clear what that actually even means in that sense. But then the whole, oh, he now no longer can breathe our air, and then there's this mysterious chemical called acid dichloride, which we were talking about right before the show. I guess there's some acid dichloride thing that he can breathe now, whatever that is. The doctor was able to tell just like one quick scan. Oh, acid dichloride. Okay.
He got out and he was like 80% nitrogen, 20% acid dichloride. Breathe, right? Tom.
Oh, actually, I had a question for you. This is at the intersection of biology and physics. Right before that, the transporter couldn't lock onto him. Do you remember that when he was still in the cafe?
Yeah.
And it's like, wait a minute, why? I mean, you usually just say like 5 to beam up and give no further specification, and you can beam okay. But for some reason, he's so different they can't even identify him as one individual or something. It was unclear why the transporter couldn't lock onto him.
That's interesting. I hadn't really thought about that before, because yeah.
It's like you can't be distinguished from the environment in some way, right? That's what I was thinking.
Yeah, I suppose it'd have to be some organic type compound that they're picking up on. But I mean, because they lock onto life signs, right? When they transport
exactly.
Specifically. So it's whatever life signature they have. Maybe he doesn't have anymore, but that seems to have disappeared super quickly.
Yeah.
And
yeah, it's true. But they can also like beam like, cylinders and stuff too all the time.
Yeah, I mean they do transport non-organic beings at all,
yeah.
but
it's true.
That is really
equipment.
interesting.
They beam equipment all the time too.
Yeah.
So I have a couple of notes here. Like there's some stuff that came up. It's funny they use the word mutating, and this is a constant thing in all science fiction. The word mutation there is used in this really general sense that like his alveoli are mutating. Like, wait, what does that mean? Like alveoli is a structure. When you say mutate, does he just mean changing? Maybe. So one thing I have to give him a little bit of leeway in the sense that this is, whatever it is, 300 some years from now. So it's possible some terms that we use today are not terms that they use there in the future. So maybe mutation is used in a much more general sense. Maybe there is something that people call acid dichloride as sort of a regular parlance thing. Yeah, it's okay.
That's a good pass.
Yeah.
That's a good shine it up.
Yeah, no, exactly. It's fair. I mean, because like there's words we use today that 300 years ago people would be like, "What the heck is that?" It's like, okay, fair.
Right.
Yeah, our jargon changes over time, and they're probably using their jargon for the future.
Right.
But I mean, the challenge, of course, is this directed mutation where he's having all these changes, and they're very specific. Say they're genetic mutations. It's not just some physiological thing. Everything's genetic mutations, but it's very targeted. It's very much like he is changing to this form, and the set of structures in his new body can now work with each other
Yeah.
You know, so I mean, the most likely thing, let's say for example, you got some big radiation dose. The most likely thing that's going to happen if you have all sort, some sudden mitosis, because they use mitosis in there too. If you have a sudden burst of mitosis, that's basically cancer, right? It's not
Right.
something. It's not like when you get cancer, you become a different person. You
Right.
just have this sort of uncontrolled crazy growth because it's not working in a way that natural selection has made okay over
And
you know
that's that,
thousands or
and that
millions.
kind of is how they're expressing it first, right?
Exactly.
They're like, weird
Exactly.
mutations are happening.
Exactly. Yeah.
Sure.
Initially, it's just this weird mutation, but then it's like, oh, look, and now there's a new heart, and then by the end, they're just like, oh, this somehow followed some process of evolution. Though, I hate this idea of a directionality of evolution. That's always very frustrating. Like, there's no directionality of evolution. It's not like you can say, oh, given the changes that happened in the past, we now know that
Right.
in this length of time, you're going to be that. Like, no,
Right.
you have no way of knowing that right now.
Because I think they said what that so well. First of all, he dies and
Yeah,
comes back.
that was also weird, but we'll set that aside.
Right. Okay. And then I think the bit that probably, because legitimately there are some Star Trek clunker episodes.
Yeah.
This is not a clunker, I'd
No,
argue,
no, agreed.
until he coughs up his tongue, and then I shut down.
There was a lot of back and forth in terms of what he could breathe to. Because remember,
Right.
when he was dead, they'd already turned down the force field. So presumably all that water that's in the air was all over him.
Right.
So I'm assuming they didn't put the force field back up when it was his dead body sitting there.
Well, that's
But
kind
then,
of, yeah.
but then later on, like so the doctor comes and uncovers him, and he's breathing again, and he seemed fine. But then they have the force field back up later when they're keeping him in there so he doesn't attack Janeway and stuff.
Right.
So there's a little bit of back and forth there, but yeah, maybe there's a transitional stage.
Yeah, right, exactly. So they do say that there is a rate of genetic mutation that's accelerating
That's
by
right.
10%.
That's right.
So that would
And
be
that you could change. I mean, that you could tell.
okay.
That's actually okay. So I have a post hoc explanation here. So it's tricky because if you think about it, like your genome is like a book, and it's a bunch of letters, and as you make a new cell, you basically just make a copy of that book. So it's tough to imagine. So at first I got stuck where, like, if you change a whole bunch of stuff, and let's say like you've done that iteratively over a long time, you can't tell what the original book was. Like, it's not like you can just say, oh, I'll make it back to the other one, unless you have a copy of that original book sitting there, which I guess there's always the transporter. So who knows if they have it there, or
Yeah.
they just have a computer file of it. But one thought I had is, since he went everywhere in space and time, what if, and again, this might be crazier than the episode.
Like, bring it on.
What if he picked up some extra nuclear DNA? So let's say some DNA that's not in his nucleus, but it's like some other, maybe an organelle, maybe just sort of like somehow floating. And let's say it also can function as a virus, right?
Okay.
So he's picked this up, and this is something now that's making copies of itself inside his cells and also hopping between his cells, which, viruses can do that.
Okay.
Okay, maybe it's like a really, really crazy fast one because it's from maybe it's even manufactured in the future. Who knows?
Yeah, right.
Right? I mean, it's great when you say like all time. Like, well, pretty much anything's possible at all time.
Right, right.
So if that's happening, maybe what's happening is he's not actually losing his human DNA, but proportionately, let's say that thing is making many, many copies, he's getting this other set of stuff, such that proportionally his human DNA is less and less. So when they say we're losing it, it's the overall signal is going away just because it's being swamped by all this other DNA there. So that would then be something that maybe then it produces a whole bunch of weird structures and essentially it's all kind of going away. But you could, in some sense, just eliminate that, and then it would be gone.
Yeah.
You'd be. I mean, any structures that were there would still be there. So this is one of the other things about every science fiction. It's not just Star Trek. Whenever there's something with mutations, they immediately start just growing stuff and changing. And it's like, okay, cells don't divide that fast.
That's like a fundamental thing. Yeah.
Yeah, right. That's like crazy, man. Just getting a new organ, or like you
Right.
with Geordi turning transparent, or or all these things,
Or
like
Barkley turning into a spider.
or Margaret turning into like it can't just happen that fast. That's crazy. But anyway, but all science fiction does that. This is true across the board, and especially like comics love that sort of thing.
Yeah.
But setting that aside, if you got rid, and I guess the other part of that is the what is it, the constant amounts of matter and energy, like to do that.
Yeah.
how much matter and energy, like did he have like a ton of food?
I mean, yeah, because that's like the whole metabolism rate.
Right.
Which, I mean, but there was a Star Trek episode where where was that one where the metabolism was increasing super fast?
Are you talking about original series, the one where they like where they sped up and then you couldn't see
Yeah,
them?
maybe that was
Yeah,
it. I just have
yeah,
that image in my mind.
yeah. Where you couldn't see them, they just sounded like this like buzz.
Yeah, exactly.
Yeah.
So we did get a couple questions in
Oh yeah.
here, and also thank you, Andy, for the gift subscription. So welcome, physics. Frozen asked a really quick question about where can we get your background. I got it from the Star Trek Online guys. So if you look up, I think Star Trek Online Zoom backgrounds, there's a whole host of those that you can find, and they are fabulous. So thank you to
Actually,
them.
for mine, I always troll the Star Trek tour places where like you can go and so they have a lot of pictures of all the different rooms. So I just snag those and they're great
Nice.
backgrounds.
Nice. And then Domestic asked, and I'll get back to physics question because I think that's a bigger question that both of us can answer. But Domestic asked, can this be related in a way to autoimmune disorders where he seems to be affected by his environment?
Yeah, absolutely. It's very similar to that. That's a very good call.
Awesome. And then let me see. Physics asked, is evolution linked to chaos theory if evolution is so hard to predict? So when they're having that conversation and they say explicitly like his rate of genetic mutation is increased, and then the doctor I think says, oh, he went through rapid evolution in a 24-hour period, he accelerated his evolution by like millions of years.
Yeah. So you can predict. You can predict with obviously there's big boundaries on this. You can predict the amount of genetic change that might happen over a certain amount of time in the future. That is actually fairly predictable. Because, you may have even heard references to the molecular clock from DNA and things like that. So you could sort of fast forward that and get some estimate of that amount of change would be equivalent to 4 million years, or I think they said 4 million years at one point in there. Yeah, I think that's right. So that would be okay. It's what the changes would be. That's the part that's a lot harder to get.
Right. Interesting. Happy birthday, Kurobachi. Yay. So yeah, I think, and then there was some.
Oh, that's a good question.
Where did I see? What did you
about
catch?
Could you have a bubble of time speeding up and evolution happening faster, like the replicators in Stargate? Could you grow new cells?
I mean, that's kind of what happens in the next episode that we're going to talk about, right? Where we talk about Timescape, where they have the bubbles of time that they're going through. But before we get to that part, with regards to the chaos theory thing, that idea that small changes can propagate, I think that's kind of what you're talking about. You can say that, yeah, your genetics will change X percentage in millions of years, but and again, we don't know what that's going to look like.
And there's boundaries on that too. It's not perfect, but you could get close.
Yeah, for sure. And then the whole idea of transwarp, I mean, they've used that interchangeably. I think just for this episode, they seem to be referring to the sort of transition between warp things. So Dracorex asked you, what are your thoughts on the fact that evolutionary changes appear to be backward? So they're evolving forward into lizard people.
Yeah. Actually, they're amphibian, but still.
Yeah. Thank you. Yeah. Good correction.
No problem. It's so this does happen. So let's use an example of whales, right? Whales look more like a fish than they do like the typical mammal. So you can have evolutionary change go in one direction, because I mean whales are mammals, so they have ancestors that lived on land that look like other land mammals, and they went back. So that's possible.
I never thought about that before. That's one of those like, today I learned this.
Hey.
Never thought about that.
Yeah, I learned lots from you from this show. So. Glad to repay a tiny bit.
Awesome. Okay, so we have this, but what they're doing really is they're jumping over trees here, right?
Yeah. Well, so they never implied that they're actually de-evolving. They just said they're evolving, which I'll give them credit for that. That's great. So the reason I cited first, because there's so much Star Trek where they say something about de-evolving. Like, oh my gosh, it's still evolution. It's not de-evolving. There's no. So to their credit, that like could a future, some distant future human form be amphibian? Yeah. I mean, I wouldn't rule that out. It's possible. It's and what's kind of strange about it is it didn't seem like, it's unclear what pressures would happen that would make that ideal, but. I mean, who knows what the next 4 million years hold for us? Maybe if everything goes to heck and we can't have technology because we destroyed our planet, maybe that would be the way we go.
Do you think that would have made more sense if Tom Paris had ended up on that planet that they eventually get to and had evolved from there into what he did? maybe.
That it might. Actually, I will say that 4 million years in the future, it's unlikely we would look that different. Because 4 million years is not that long in an evolutionary time.
Okay.
Like if you think about our ancestors from 4 million years ago, pretty much look like people.
Oh,
They're
okay.
basically there would be something you might call a caveman. It would be just before the Australopithecines and stuff like that. It's not.
Gotcha.
They wouldn't be amphibian. That's a very dramatic change. That's way more than 4 million years out. Especially an amphibian that couldn't breathe regular air. Like, okay, that's like you're going to crazy levels of change there.
Okay, that's good to know because I operate on like space scales. So for me, plus or minus 4 million years, I'm like, yeah, sure, that makes sense.
No, that's spitting time in evolution.
Gotcha. Okay, interesting.
Yeah, but I think in the 4 million, I don't think they said it was 4 million years in the future. I think he said based on the last 4 million years and then extrapolating forward. They didn't necessarily say there's a reason it's potentially okay. He didn't say based on that for the same length of time in the future. So
got it. Interesting.
So it's funny. It's funny why you would pick 4 million years then. Like, why wouldn't you use like the last 500 million?
I mean, right, you use everything at that point. So it's just like, what is going to make people go, that's weird.
Yeah, they probably just pulled that number out of a hat.
I mean, that's
actually, I was curious if they said 4 million or billion. I had to pause and play it a couple of times because 4 billion would be all of life.
Right.
But he definitely said million. I played it. I was like, oh, okay, it's million.
And for someone who's not a biologist like me, saying 4 million, I'm like, sure. Okay. my scale of evolution, I don't have one, so
fair.
If they said 4 billion, I'd be like, but Earth wasn't.
Yeah, right. Exactly. You know that one very well.
Yeah. So physics asked, Domestic asked first, since he was at every point in the universe and exposed to every virus of every humanoid species at once, what would be the results?
It would be bad.
Bad.
I'm assuming he doesn't have resistance to all those things. Now the question is like he was exposed. It says he like sort of passed through. I mean, he went through every sun in the universe too. I mean, so it's unclear he would pick up all those different things. That's why I was hypothesizing that there's just like one that he picked up from someplace.
Right.
Because again, I mean, if he was everywhere, he was in like crazy temperatures everywhere.
Yeah.
And stuff too. So. And
then would 4 million years in an irradiated environment change your situation? Does that accelerate the
more likely answer is it would just kill you.
Right. Okay. Valid.
But yeah, realistically, it probably would. It probably would do something where you could imagine that maybe the rate of change would be a little bit higher. It's fair.
Awesome. And then Dracorex has an awesome question here. Involved amphibian forms seem to be unaware of themselves. It seems odd that a large brain would evolve to lose intelligence.
Yeah, the only thing I could think of is, again, if you imagine some cataclysmic situation somewhere in the future where just like, the only thing we can do is just survive and breed. And that happened for like a long time because we destroyed our planet or stuff like that.
Right.
I guess, maybe at that point there wasn't so much of an advantage to the big brain. I mean, see, it's one of the things you think always that, having a big brain is always useful. But, a big brain's also very energetically costly and things like that. And if there's resources right there and the best thing you could do is just breed.
Yeah.
Which clearly they could do that.
Yeah. Yeah. That's, I think, exactly the direction they were going in.
Yep.
So, awesome. So the last final thought before we move on to the last one, they fix this with anti-protons. I honestly don't have an answer for this.
I don't have an answer for that. I was going to ask you if you had an answer for that. I was like, I have no idea. I don't even really, I only vaguely know what an antiproton is from your show.
Yeah. When they talk about the antiprotons, they're using it correctly in the sense that they're saying, look, this is indicative of like warp technology because we use antimatter and maybe the exposure to the warp drive or the nacelles, would affect this. So let's try to drive it in that direction. But antimatter, if you're gonna force an increase of antimatter, I don't know how much research has been done on like a proton affecting an entire like molecule or atom, because if a antiproton meets a proton, and these all do exist, if an antiproton meets a proton, they obliterate themselves and just turn into light. But I don't know how much, like, if a high amount of antiprotons, because they're not very long-lived, which is why they're hard to study, because they run into protons and then disappear. But if they ran into, if you had a high bombardment of antiprotons onto molecules, does that destroy the molecules? Does it change their form? I have no idea. This is where physics as biology.
Oh my gosh.
Oh my
gosh.
Awesome.
It was fun to revisit the episode, though.
Yeah. So any final thoughts before we part ways on this one?
No.
It's not as bad as I remember.
No, that's true. Honestly, I was thinking that as I watched it too. Like, it could have been a lot worse. I mean, honestly, there's a lot of sci-fi that does not try nearly as hard as this did. And this one, you know, there were efforts in there.
There were efforts in there. It just, for me, it just got gross.
Yeah.
I was like,
Too much squishy.
Yeah, exactly. Too squishy for me. So anyway, thank you very much, Mohammed. I really appreciate you here. You got to go catch some fruit flies,
I
right?
do.
All right.
I do indeed. Thank you so much for having me.
Of course. Thank you. And
Take care.
we will.
Thanks, people in chat.
We'll do this again after
Looking forward to
season
it.
3 of Discovery. So.
Looking forward
All
to
right.
it.
Sounds good. Have a good one. Thank you.
Bye-bye.
All right. So while he signs off there, you are just left with me now. And we are going to now talk about Timescape. So, Timescape, this is TNG, Season 6, Episode 25. This is where they're coming back from a conference on the psychological effects of long-term deep space assignments, which is kind of funny because, like, this is a couple years before Voyager. Voyager had to be at the concept phase at this point, so I kind of like that they threw that in there because that's the end. And yes, thank you again, Mohammed, for being here. That was really good. I'm glad you're here to cover all the evolutionary side of things. I'm not opposed to this episode, Andy. I think this one's okay. So to just recap this, it just has some moments where I feel like I've watched this episode, I think 3 times in the last 6 months. I still don't understand how they solve it. There's some ways that they're throwing around this like time solution that they have and why time is doing what it's doing. And I'm literally like trying to catch the explanation and it's not ever coming to me here. And yeah, Dracorex, I've heard that story as well. I think it's really good until Tom Paris coughs up his tongue, and then it just is like, oh man, and it just goes in a direction I wasn't expecting there. And thank you, A. Harvey, for the quote about Deanna Troi at the beginning. So generally, quick synopsis of this episode, if you didn't get a chance to watch it. They're coming back from this conference, hilarious conversations that we'll get into in a second. They're coming back from this conference, and then they are, essentially, Deanna experiences time freezing, so she sees everyone else freeze, and then they all appear like nothing happened, and then she freezes, and what we don't see that time has frozen for her. She just picks up where she was, and suddenly everyone's in a different spot, and they're like, dude, you were out for like 3 minutes. Which I kind of like. I really, really, really like that. We've had lots of different time frozen ways of depicting it in science fiction, and I think this way was one of the best examples of that, where we got to see her experience it both directions. But basically, we have Deanna Troi, Picard, Geordi, and Data are all on this shuttle. They're trying to get back to the Enterprise, and these time fractures start happening. And they're not necessarily detecting anything in particular that's off. They're just seeing these like time bubbles that are happening, and stuff seems to be frozen. They find that like the starboard antimatter pod is completely drained, that it seems like the starboard engine was in use for a good 47 days. There's a really gross scene that they actually used, I think in Orville as well, where Picard stuck his hand into this like rotten bowl of fruit and then starts screaming because his nails are like super long and he had this rapid aging that happened. And essentially what they find, all of these temporal disturbances are going on throughout the region, and then they come upon the Enterprise that's like frozen, appears to be frozen in battle with the Romulans. So these time fractures that are going on, this I don't necessarily have any problem with. I think it's kind of a cool idea. They're able to isolate all these bubbles. They're able to study them enough that they say like, okay, so we have this region on the shuttle where like from that cantina, cafeteria, whatever, bay, where the food is, out from the ship. I think they say extending 17 meters beyond the ship. Time is aging 50 times faster than normal. It's a spherical shape. They try to get away from it. They can, but then they're seeing more temporal disturbances that are going on. They have random configurations, random sizes, and they basically say time is moving at a different rate throughout all of these. I mean, if we think of time as a dimension and your ability to progress through time at a fixed rate, they're messing around with space-time so much in the future with warp drive and, transporters and all of this, subspace comms and all of these things, that this idea that you could have regions where, for some reason, space-time is experiencing what we would call a dilation, either an acceleration or a deceleration, where you go into it and time is going faster or slower than it is for you, that would just be a massive distortion in space-time. I mean, we see that. That's the, gravitational time dilation. That happens. GPS satellites are going fractions of nanoseconds faster than our clocks because we are deep in a gravity well here on Earth. So gravitational time dilation is a thing. Now, these distortions aren't necessarily caused from gravity here, but they could be something similar along those lines. And yeah, Aaron, the Delta Triangle from the animated series, was that the time trap episode? I think I actually had that to be voted on, but not enough people wanted to discuss it because I wanted to discuss it, but that's fine. And Physics asks, could they be the arse end of the back of a black hole or wormholes of different mass? Yeah, I mean, that's essentially the issue is that you just would have to have something causing that distortion in space-time. I mean, but temporal anomaly, sure. You have one stretching in one dimension where, it's like, let's translate that to space as opposed to time. Where you have an area where 1 meter actually takes you longer in one spot to cover than it would in another spot. That's just a space-time distortion. We don't see these. That's some aspect of special relativity where your distances and time are all relative. But again, those are kind of special cases, and they usually break your brain a little bit. But inertial reference frames, all that fun stuff. But these, temporal distortions I'm good with. The thing I'm most excited to talk about is coming up, though. But they do say the space-time continuum is shattered. I like that. You can think of it that way. If it's shattered, you get these distortions all throughout. And then they're finding the center of these disturbances is where the Enterprise is. And like I said, it's frozen in this battle with the Romulan ship. They decide to build a subspace force field around themselves so they can go on the ship. And I really like that because they immediately realize that if they just beamed themselves there, they're going to be frozen as well. That kind of harkens back that it's consistent, which I like. Storytelling wise, it's very consistent. I appreciate that. And it kind of harkens back to the Blink of an Eye Voyager episode where the guy goes up onto Voyager and he's experiencing the time dilation as much as, so for a half hour for him, he's losing decades back on his home planet. So they're keeping it very self-consistent here. And then, yeah, Andy, they basically say we're going to build a subspace force field around themselves because they have emergency transporter armbands that allow for a sensitive enough phase discriminator. And we've talked about these a little bit before. If you think about space-time, light, all of these, so think about our existence, not as particles, but as waves. There's lots of sort of quantum mechanics gets into a lot of that as well. We're all just probability fields at the end of the day. That a phase discriminator would be able to isolate those wave packets that are making up everything. And so that can isolate your wave packet from the surrounding area to keep time progressing normally as it would for you. And that's kind of where this ties a little bit back to what we were trying to come up with an explanation in the last episode, was that maybe you could just build this pocket where time is different than everywhere else. And yeah, Andrew, it always reminds me of the Futurama episode where Bender's tanning and he says, oh, photons, I don't know if you're waves or particles, but you sure go down smooth. And if you don't think that I say that every single time I go to the beach, you would be mistaken. And I go to the beach a lot. So anyway, we have so they build this bubble, but the thing that surprised me, because we've seen this in other iterations of Star Trek, and I didn't realize that it harkened back as much to TNG, was mobile transporter devices. Now, they're emergency use only, so maybe it's just because they require a lot of energy, they're one-time use, they fry the first time you use them, which would be, they use them a couple times, but maybe you only get a couple of uses out of them. But they have these arm band transporters, and they're able to jump between them. And yeah, I mean, we saw them in Best of Both Worlds. Is that TNG or DS9? I forget the episode name. Sorry. Anyway, but I like that. It was kind of cool. Throw on these armbands, these mobile transporter devices. Thank you, TNG. There were Klingons involved. I was getting it confused with a two-parter where Worf shows up from DS9. Yeah, that's right. Thank you. And yeah, so you're able to use these, and they build this subspace force field. Now, remember, we talked about subspace basically removes you from normal space. It's outside of your sheet of space-time. So, you know, to pull that analogy thread, when you're removing your time dimension from the time dimension you're currently in, then you're able to, then you could say you're existing in subspace. So that's okay. Now they talk about, let me see, they get to the ship, they get to the Enterprise, they have their subspace force field. Oh, makes Deanna Troi kind of lightheaded, and he says, you've built a different pocket of time, so it's messing with your equilibrium. I like that. That was like what we saw in Dark Matter, where they talked about temporal inertia, that your body isn't used to being slightly out of phase with time. I like that one a lot, and I didn't say that explicitly, but that's kind of what I inferred on this one. And then what they realize, they go to the ship, they see all the Romulans, they see the people on the Enterprise, they go to the Romulan ship, they see everything. They also see the warp core breach is in progress. Data realizes, because it's within his visual detection threshold, which I really like, that time is moving forward, but incredibly, incredibly slowly. And I like this idea that Data basically has a frame rate that's faster than our own eyes. I kind of like that. That kind of works. Once you get into like the psychology of brains and how much our brains infer what our eyes are only able to process at a certain rate, mind is blown. I have to remember, I think Stephen Grenade, my friend from DragonCon, he posted a thread about how when you move your eye rapidly, your eye is not actually seeing certain portions, but your brain is filling in the blanks. Just mind blown. Cool stuff. And Andrew mentioned, wouldn't taking yourself out of one frame of reference and holding you in another need a lot of power? I would suspect so. Yeah. But that's also, that kind of holds true with them needing these emergency transporters. There wasn't any other technology on the ship that could sustain that. So if they were trying to say, okay, it would need a lot of power for you to be able to be held out in a different frame of reference, what do we have that could do that? And then thinking like, oh, okay, if we, what do we have on the ship that would require a lot of self-isolated power? We'd say emergency transporters. I think that's okay. I'm okay with that. But they realize that time is moving forward because, yeah, Data's able to actually detect that time is progressing, albeit very, very, very slowly. And Picard gets all giggly at a little face in a cloud, which I swear I hallucinate every single time. And the funny thing is because, again, watched this episode a lot recently, once he gets to that cloud and the warp core plasma breach that's happening, he, is so serious as he's going up and explaining it. I'm like, did I make that up? Was that an outtake? Even when I was watching it this week, I was like, does that scene actually happen? And then immediately he starts giggling, and then there's a little face in the plasma. It's so weird. It's so weird. Whatever decision process went into that, I love and am terrified by. We'll say it that way. But yeah, it is hilarious. Oh, yay, Frecked Chemist. Yay. I'm glad you're here. Awesome. Happy to have you. And we're getting to my favorite part. So, excellent. The Romulan Engine. Yeah, I love this so much. So what they realize, oh, that's okay. That's what I thought. That's what tripped me up. Freckled Chemist. We'll go with it. No worries at all. Okay, so they basically trace this back. They realized that it wasn't a battle between the two ships, that they were doing a power transfer in progress when time decelerated. So they go to investigate all of this. They realize that the source of this issue is coming from the engine of the Romulan ship. And what they say explicitly is that the Romulan engine uses an artificial quantum singularity. And that's where this is coming from. So before we get into how they fixed it and everything, what they realize is that there's this alien species that puts their young... it's so weird. I love it. They put their young into a black hole as their nest. Sure. That's how this species does their thing. And okay. All right. They incubate their young in a gravity well, a black hole. And they say very clearly here, this isn't them talking around a black hole. It's that they incubate their young in a black hole. And they mistook the engine of the Romulan ship to be a black hole. And the way that they're talking about it, this being an artificial quantum singularity in their engine, is similar enough in structure to a black hole that that's what they were able to detect. So let's talk about this. And yeah, Andrew, depends how you talk about it with the term quantum singularity, but I really like this idea. And I remember someone asked me this when I first started giving my Science of Star Trek talks. Good God, what was that, 7 years ago or something? That someone said, well, what about the Romulan ship and how it runs on a singularity? And once I thought about it, and we did this, and we were talking it through, it blew my mind, because it's the idea that you basically, this is the way I think about it, not necessarily in front of your ship, but in front of the important part, the bit that's going to pull your ship along. You're basically dangling a gravity well. You're dangling a carrot. And your ship is going to be constantly falling into this black hole. But as it starts to fall in, it keeps moving ahead. And so just like the astronauts at the International Space Station aren't, they're falling around the Earth, which is a common misconception. They're actually only in low Earth orbit, so they're experiencing gravity, but they're in constant free fall. They're on a free fall ride at a, theme park from hell as far as I'm concerned. But they're launched out, and the International Space Station is essentially, it's just falling to the ground, but it's falling so fast that the Earth curves away from it before it can hit the ground. So it just continues falling. And that's exactly how the Romulan engine works, is that they're dangling this black hole as their engine, and the ship is falling into it. And then as it falls, that, because it's part of the ship, it's moving with it. So you're constantly falling into it. I kind of love that. I super love it. So Andy was asking, how does it go FTL? That's a great question. And honestly, I don't have an answer for you, because that doesn't make it go faster than the speed of light. That's just how they use their engine. But, the Starfleet ships have impulse drive and warp drive. So they could have different mechanics for each one. This could be their equivalent of their impulse engine, maybe. Although that being said, they kind of interchange them with this quantum singularity drive. But, but you could use the same concept, just like we were talking about in the last one, where your ship is moving at a speed and then you build a warp bubble around that. That's kind of what the warp core builds that engine. They could have multiple components where one is pulling the ship along, that quantum singularity, and then some of the energy from that drives a bubble of space-time around your ship. And and conservation of inertia. That's a good point, Mutant Bob. I like that. But I love that this is how the Romulan ship's engine works. Love it. Quantum singularity. And like I said, it's not even like they were. That's where I think Andrew, like with with Andrew with Doctor Who, I think that seemed to be more throwing around the term quantum singularity. And we're like, sure. Yeah, we got a tesseract. Tesseracts are 4-dimensional. 4 dimensions are time travel, wormholes, things. They don't tend to. Doctor Who doesn't necessarily lay into technobabble, which is fine. Star Trek does, and the way that they're discussing this quantum singularity is brilliant, and it super works. But to the dismay of this random alien species that went like, "Ooh, black hole," and went into it, and then things went kablooey, and it. Oh, yeah, that's a good point. It's been a while, but I am devoted. But it's been a while since I saw an explanation for how the TARDIS works. Okay, so how the hell they do this and fix it, and hi, Uncle Bill, is tricky, and we don't have an answer for this. And physics, with Hawking radiation, I would say, like, the level that they're at with using this artificial black hole to drag their ship along, the idea is if Hawking radiation exists or not, I would expect has long been answered, and it's just something that our puny pre-warp brains are still trying to wrap our heads around. But I do like that, so that works. So yeah, Data scans it with the tricorder, and then time progresses, and then things go kablooey, and then it reverses backwards again. And they go, oh, the tricorder managed to move time forward and then back again, so can we reverse it so it goes back in time and then forward again? And also, Geordi died, but he's in a different time stream, so if we go back in time, we can pull him out of that time stream and keep him from dying. And at that point, my brain is like, I'm done. And I'm pretty proud of the amount. So we can, in real time, try to solve this. So by all means, if you have an explanation for this that you have kind of understood in your head, please throw that in here. I'm more than happy to. I like that. I am more than happy to try to science this in real time. All I'm saying is that I've rewound it, I've watched it, and every time they're talking about how the tricorder, I've written these down in great detail. The emissions from the tricorder caused the aperture to activate. Now, this aperture being this spatial distortion thing that's causing these issues. The nest egg, I guess. Tricorders are active scanning devices, so it emits a pulse of some sort, probably electromagnetic, but it could be, future technology. But it's an active scanner. You have to use it. You have to scan people, so it pokes something out and pokes back. And it could be reading signatures itself, but there is some, if they're saying tricorder emissions, that means there is some active scanning going on. I'm trying to think of a good analogy. I know there's good analogies for this. Ultrasounds. Ultrasounds versus not X-rays. X-rays are also similar to that. Heat maps? Infrared radiation? Sonar? Well, yeah, but like sonar is also active radiation. All of those. I was trying to think of something on the human body. But yeah, so like sonar, ultrasounds, X-rays, those you're like pumping with some frequency, getting the reflected information back. Oh yeah, that's true. If you're just listening, yeah. That's fair. Ears. Thank you, Mutant Bob. You win. It's been a long day. So yeah, this passive scanning versus active scanning. But aside from that, we can assume that the tricorder does some active scanning, that it's sending out an emission thing and then it's bouncing and it's coming back, because it says those emissions cause the aperture to activate. Because we don't know how a tricorder works, if it is just electromagnetic, if it's subspace radiation, if it's, graviton emissions. They never, and those are all made up, tachyons. They never go into all the details of a tricorder, just saying that the tricorder is emitting stuff, and that is causing this aperture to activate, that is making the time go kablooey, and then they go backwards, and then they just run it backwards and undo it, and then everyone's better again. So I don't know which conclusion. We could try to take an in-chat vote on which had the more ridiculous solution from a science perspective, Threshold or Timescape, because both of them are just kind of like, and we fixed it. In Threshold, they bombard him with antiprotons because reasons, and here they reverse the process of the tricorder scans to move time backwards and then forwards again. Everyone's saying Threshold. So 2 votes for Threshold. And you gotta set your tricorder not to try to auto-connect to the Wi-Fi. I like that one a lot. Okay, most people are going through Threshold. And Ask Todd Anything. I always thought it was supposed to be in a City on the Edge of Forever callback. I like that, where Spock recorded the Gordians playback, so I thought that was kind of a callback to that. I like that a lot. So most people seem to be going for Threshold here. And I suppose it's because at least they set up a little bit better the explanation with the time, because the whole premise, the whole arc is going, oh, time is frozen, and then it's accelerated, and then it's decelerated, so let's do that, and then it'll be fine. So at least they've tied it into the overall story arc, and they weren't just like, we fixed it. Which I guess in your own special way works too. But, prophetic. Turn the tricorder to boop instead of beep. I like that. And, yeah, because reasons is one of my favorite things to say. And yeah, Aaron, the ancillary science and Threshold is also goofy, so it's much more of a mess. I think that's probably fair as well. I mean, they're throwing around some peak technobabble in Timescape, but to the sense that, like, it sort of works. Like, it sort of works. In Threshold, you're just, like, because it's, okay, we're going faster than Warp 10. Cool, awesome, and now we're lizard people. You're like, what? And in this one, at least, it's kind of, there's a consistent story going on here. But, I mean, we're comparing an episode of Star Trek to Threshold. Threshold is, like, notorious for its hot mess, so I guess it's always gonna lose. As close to my heart as it lives. It's good to see. Any other... Alright, so some last minute to wrap things up here, some last minute observations that I love. First of all, love the discussion about the conference, because anyone who's been to a scientific conference has had every single one of the experiences that they're talking about, from the creepy dude hitting on Deanna Troi to Picard being in a seminar where he's literally like giving the wrong seminar but won't shut up so no one can tell him that he's giving the wrong seminar. Not Picard, the guy that was presenting, who talked in the monotone voice that they couldn't interrupt. And then Geordi got to touch a plasma field. And Geordi, basically, I love... It reminds me so much of, like, the legitimate comedy science fiction where they're like, how did it feel? And he's like, it was a warm and tingling sensation, like I was bathing in pure energy. And it's... Dude, that's gonna give you cancer. So hard. That's not good for you. That's, you know, I feel like that's a Futurama joke waiting to happen, where it's like, it tasted like purple. Not healthy for you. Yeah, good times. I do like that Data just straight up is like, you sure you're okay? And yeah, good times. And as we mentioned to Andrew kind of at the beginning, this warp 10 definition and how ships define their warp 10, we can kind of allow it to be fluid, but whether you're calling it warp 10 or your scale is slightly different, the idea that there is an asymptote to your exponential increase in your warp bubbles makes sense. However you're defining your warp factors, that's up to your own device. And oh no, Andrew, you lost video. I think I'm still okay. I hope. I don't think I clicked anything. Although knowing me is possible. But I mean, but we're close to the end. So that was hilarious in all its right. And I mean, you're not wrong, Laura. Threshold won an Emmy, so good times. Can I science the city of Stratos? Oh, jeez. Let me see. Let's pull some deep cuts here. Oh, jeez. Oh, man. I mean, you asked me a yes or no question, so we'll go with no. I'm not being an ass. I just, that's the Cloud City, isn't it? Yeah, that is the Cloud City one. The Cloud Minders. Good times. It operates on whatever Lando was mining. So that works. Or no, what was it from BioShock Infinite? The quantum, oh god. Whatever research that Rosalind was doing that allowed Columbia to float. The answer is in BioShock Infinite. There we go. Awesome. All right, so we're over the hour. And there you go, prophetic. Today I learned Tom Paris has been inside of everyone ever. On that note, so if you haven't followed my stuff before, welcome. We got a few new subscribers and followers as we went, and I really appreciate all of that support. If you hadn't seen my announcement from last week, we're going to be changing some things up. So this is going to be my last month doing a weekly episode club, because we're basically I burnt out with the amount of time it's taken all week, and there's other projects that I want to focus on. But I love doing this. So what we're going to do is, this isn't going away forever. Do not get me wrong. This idea of the episode club is still going to be a thing. It's just not going to be a regular thing. We'll save it for when there's new episodes of something coming out or a new random movie comes out. If anyone wants to talk about the science behind something, always contact me. I have zero problem with that. Easiest to find me on Twitter at Dr. Aaron Mack. Just shoot me a DM. I don't tweet at me. Just say, hey, I love this episode. Can we talk about it? And I'll hop on and we'll do a live stream episode club about that. And but doing it week to week, that's going to be ending at the end of this month. So next week, I'm so excited for this, because when I got started doing all of these weekly this year, which I've been doing, I think, since March, which is kind of bonkers. One of my new favorite shows aired for the first time, and that was Avenue 5. And if you haven't seen Avenue 5, we're going to discuss it next week. I love this show so much, and the science in it is bonkers. But I think it's bonkers good, but I haven't sat down and actually calculated this stuff yet. So, if you haven't seen Avenue 5, it is only 9 episodes. You can get it on HBO Max. You can get a trial period, whatever works for you. 9 episodes, burn through it. It's Armando Iannucci, Veep, thick of it, style humor. So brace yourselves for that. Starring Hugh Laurie. It's a space cruise gone terribly wrong. But they have some... It's the entire... I mean, I couldn't believe it when it existed, because it was a space comedy written by Armando Iannucci, whose entire story arc is rooted in gravitational physics. So what we're gonna do is, yeah, and Aaron, if it wasn't a bingeable show for you, that's fine. But I'm giving people enough heads up. Hopefully you can try to get through it. At the very least, I would recommend watching episodes 1 and 2 and episode 4 and episode 8. So easy to remember there. 1, 2, 4, and 8. Just double it every time. And we have Ethan Phillips, whom I've met a couple times on the Star Trek cruise, plays a astronomer, or a astronaut who's giving talks on science on a cruise. And it's fabulous. It's fabulous. So anyway, again, I'm giving you the heads up. It is not for everyone, but there's some hilarious science in it. And so we'll be talking about it. And drum roll to end up, we're going to do a 2-hour long episode club next week to close things out. And we will talk about the entire science behind Avenue 5. But like I said, if you can only handle a couple episodes, watch 1, 2, 4, and 8. And that should be good. And anyway, thank you. I appreciate everyone. I appreciate every single one of you. Please take care of yourselves and each other. Stand up and stretch. Grab some water. Remember to wear your mask outside. I love all of you. Science rules. And I will catch you next time. So let me see if anyone's on. It's typically at the end of the day here. So I'm not seeing anything going on right now. So we will call it here. But thank you all again. And I will catch you next time. All right. Oh, I'll be back next time being Friday for Astronomy 101. All right. Thanks, everyone. Bye.